In the last lecture, we derived a relation for translational partition function, which is basically given by this qt is equal to 2 pi m kbt upon h square raised power 3 into volume. And we wrote this relation as v upon lambda cube. Here this lambda, which is basically equal to h upon 2 pi m kbt raised power half. This is simply called as thermal de Broglie waveguide. So, keeping these two relations in mind, today we will try to solve some of the questions which have been asked in various exams related to this translational partition function. So we will first take an example here. Example 1. Calculate the translational partition function of hydrogen molecule. Temperature is given at 25 degrees centigrade, and this is confined to a volume of 100 cubic centimeter, and with mass of hydrogen molecule is equal to 2.016 atomic mass unit, which is represented simply by U. Okay. First, we will convert some of the given quantities into the SI units. First, B is given solution here. We will write it as B is equal to 100 cubic centimeter. If you change this into cubic meters, it will be simply 100 cubic centimeter. The unit in which you have to change, write that in the numerator. Suppose we have to change it into cubic meters. Now make this cubic meter equal to in terms of cubic centimeter. We know 1 meter is equal to 100 centimeter, so we will simply insert here 100 centimeter whole cube. That means simply this cubic meter and this 100 centimeter whole cube can cancel out, so we are simply multiplying it. So this is the easy way when you convert it one unit into other. Okay, so simply we will write here 100 cubic centimeter into cubic meter upon, this will be 10 raised power 2 multiplied by 3, it will be 10 raised power 6, 10 raised power 6, and this will be cubic centimeter. Here you will see that this cubic centimeter and cubic centimeter will go, and you will get 10 raised power 2 into 10 raised power minus 6 cubic meter, which will be simply equal to 10 raised power minus 4 cubic meter. That means we got this quantity basically. So this is how it is converted into cubic meters. Next quantity which is given in this question is mass, which is equal to, but that is given in atomic mass units. Now to convert into kgs, we have to simply multiply by 1.6605 into 10 raised power minus 27 kg. Okay, and the Planck's constant is also equal to 6.626 into 10 raised power minus 34 joules second. And temperature is given 25 degree. We will convert that into Kelvin scale. That will be 298 Kelvin. And Boltzmann's constant is equal to 1.38 into 10 raised power minus 23 joule per Kelvin. So we will now simply use the Broglie wavelength here, thermal de Broglie wavelength. That means lambda is equal to h upon, we will use this relation here, 2 by m kBT raised power half. So it will be simply, we will insert the values here in place of this h Planck's constant. So we will simply introduce 6.626 into 10 raised power minus 34 joules second upon just 2 into 3.14 multiplied by mass is given, so we will convert that into kg. So it will be 3.348 into 10 raised power minus 27 kgs, multiplied by the Boltzmann's constant 1.38 into 10 raised power minus 23 joule per Kelvin, and simply by temperature, that is 298 Kelvin, and this square root of the whole term. So this will be simply equal to, first we will solve these parts only, and then we will multiply the power terms and take the square root of the whole term. So it comes out to be 0.0712 into 10 raised power minus 9 meters. And sometimes if it is asked in nanometers, so this will be 10 raised power minus 9 will be simply equal to nanometers, or you can change this into meters. So it will be 7.12 into 10 raised power minus 11. That simply we will write it in this scientific notation here, 7.12 into 10 raised power minus 11. So this is sometimes also equal to, you can change that into picometer as well, that is 71.2 picometer. So basically we are concerned here with this value, that means we have changed this into the meters. Okay, simply now we will insert these values into this equation. That means translational partition function will be equal to volume upon the de Broglie wavelength, cube, which will be equal to 1 point, volume is already given, we have changed that into meters, so it will be 1.0 into 10 raised to power minus 4 cubic meters divided by 7.12 into 10 raised to power minus 11 meter, but it is whole cube. So first we will solve this part, so it comes out to be 3.77 into 10 raised to power 26. It will have no unit because cubic meter will cancel, so translational partition function, or in general partition function, they don't have any unit. So what is special about this result is, if you concentrate on this, so this result basically shows that even at room temperature, we have considered the room temperature condition, that means the 25 degrees centigrade, about there is power 26 thermally accessible states are available. We have considered a simple and very light molecule. So there is about 26 thermally accessible states are available to this light molecule, light hydrogen. Many states are occupied if the thermal equilibrium wavelength is small. You have to remember this point. We have also confirmed it by using this simple example. Small compared to the dimensions of the cube. Now, if we take a deuterium molecule or a deuterium molecule, that means the two molecule, which basically has double the mass of the hydrogen atom, hydrogen molecule. The translational partition function is about 2 raised power 3/2 times log. So if you take the deuterium molecule in place of the hydrogen molecule, we will find that its translation partition function is basically to the power 3 by 2 times larger. How we will see it through this example? Now that means this translational partition function for deuterium molecule is basically equal to if for hydrogen molecule it was 2.77 into 10 to the power 26, it will be 2 into 3 by 2 times that much, that comes out to be 7.8 into 10 to the power 26. We will see here this translational partition function we know is equal to 2 pi m kBt upon h square raised power 3 by 2 into v. This can be written as this m. You have to remember mass of one molecule is basically equal to molecular mass divided by Avogadro's number. So in place of this mass of one molecule, we can introduce the molecular mass upon this Avogadro number. So we will get this type of relation then. 2 pi, here it is capital M, that means the molecular mass kBt upon h square. Now this Avogadro number as well, 3 by 2 into volume. What we do, we will take this outside, this molecular mass, this temperature outside, we will write then 2 pi kBt upon h square and a. These all terms are constant basically, so we will write them separately into this m raised power 3 by 2 into temperature is over 3 by 2 and volume. Simply what we have done, we have simply taken this outside out of this whole power 3 by 2, so simply we got these terms. Now if you are asked to find the translational partition function with respect to other, that means we can then simply use the relation. Suppose this is translational partition function of one molecule, this is our translational partition function second, and we can simply introduce these items. That suppose this is molecular mass of 1 and temperature of the same and volume. That means we can compare the results. It is 3 by 2 and P2. This is simply for how to solve questions based on this. So from this discussion basically we got this. Now if we take a situation where the volume is the same, that means V1 is equal to V2 and also temperatures are same, V1 will be equal to T2, then it is simply this V1 and V2 will go and temperature will go. That means we can simply write the translation partition function 1 for second will be equal to basically the ratios of molecular masses whole raised power 3. This is very important relation. If you want to solve some problems, so you will have to use this simple relation. For example, we have done for hydrogen and deuterium, that means for hydrogen molecule and deuterium molecule, we can simply write the translational partition function of suppose this deuterium upon translational partition function of hydrogen. They will be simply in the ratio of here molecular masses. So we can write molecular mass of deuterium upon molecular mass of hydrogen. So it will be 3 by 2. So it is given, it is 2, it is 1, it will be 2 raised power simply 3 by 2. What we have already discussed while taking this example. Similarly, you can use this relation for example, this translational partition function of you have to find the translational partition function of carbon dioxide. So you will simply use with respect to hydrogen molecules. So we will simply write the first to the ratio of translation partition function of hydrogen here, hydrogen molecule. So it will be simply the ratios of molecular masses. 2 raised power 2. So we can further simplify this. That means we can take this part to this and multiply it. That means we can simplify the translation partition function of carbon dioxide molecule. So molecular mass of carbon dioxide is equal to 44 on, and hydrogen molecule it will be 2 raised power 3 by 2 into translation partition function of hydrogen, which we have already found. We will introduce that value here. That means in the previous example we will take that value equal to 2.77 into 10 raised power 26. So it will be equal to 2.85 into 10 raised power 8. So this is how questions based on this translational partition function can be solved. We will take another example. This was basically asked in CSIR net. The question is the single particle translational partition function. They have represented that simply by F. For an ideal gas in a fixed volume, V depends. This was a very simple question on the thermal entropy area. They have given this dependence also here. That means this thermal wavelength. They have written as this partition function is directly proportional to this, equal to this thermal wavelength, the probability length raised power. We were supposed to find this n value, where n is equal to. So first option was here, n is equal to 3, second was n is equal to -1, third option was -1, and the fourth was -3. So it is very simple. We know the translational partition function is equivalent to in terms of thermal entropy wavelength V upon lambda K. They have simply represented this partition function here with F and lambda with this lambda thermal. So it is one and the same thing. So if at fixed volume it is also given That means this volume is constant. We can simply write this translational partition function will be directly proportional to this thermal wavelength raised to power 3 or this. So here if you compare this n and here it is simply equal to n is equal to minus 3. So option number 4 was right answer here. So one more question which was asked in December 2018. The question is the translational partition function for ergon confined to a volume of 1 liter at 300 Kelvin, having thermal wavelength of 1 point. Thermal wavelength was given here into 10 raised to power minus 11 meter is yes. So the options there, first option was 24.4 into 10 raised to power 29. Second option was 2.44 into 10 raised to power 29. Third option was 0.244 into 10 raised to power 29, and the final option was 244 into 10 raised to power 29. So it is very simple. We will simply use this translational partition function is basically equal to V upon lambda cube. V is here given equal to 1 liter. You have to simply change into cubic meters. It is very simple. It will be 1000 cubic centimeters, and that will be equal to 10 raised to power minus 3 cubic meters. And lambda is equal to 1.6 into 10 raised to power minus 11. Now we will simply introduce these values into the above equation. So the translational partition function is basically equal to 10 raised to power minus 3 cubic meter upon 1.6 into 10 raised to power minus 11 cubic meter, and cubic meter, and here simply this cubic meter and cubic meter will go, upon multiply with 3 times, so it will be 4.096 into 10 raised to power minus 33, which will be equal to 0.244 into 10 raised to power 30. Or we can write it in this form, 3.44 into 10 raised to power 29. So the option that was right will be the option number that is right. So this is how the question is based on translational partition functions are solved.